Hello everybody, welcome to our 7.4 beginning lesson, day 1. And we're going to start off by just a quick warm-up and review some of these concepts that we've done in the past. So we're going to do this simplification here. So remember to take care of the square root of 32. 32 is not a perfect square. I want to find a perfect square, the biggest perfect square that's a factor of 32. So remember your perfect square list, is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. Okay, the biggest perfect square I could do with 32 would be 16. So I could make that then the square root of 16 and the square root of 2. And the reason I did that is because the square root of 16 is 4. And so I'll have 4 square root of 2 as my final answer. Moving on to the next one. If I tried 54, the biggest perfect square in 54 would be 9. So for 54, I could make that the square root of 9 and the square root of 6. And I did that because the square root of 9 is 3. And then I'm left with the square root of 6. Now I know square root of 6 as a factor can be factored, but not by any of these numbers over here as perfect squares. So that's just going to be 3 square root of 6. Now let's move on to the next one. And remember, you cannot leave a radical in the denominator, but before I rationalize it, 8 can be simplified. All right, 8 has a factor of 4 in it, so I could do the square root of 4 and the square root of 2, and the square root of 4 is 2, so my denominator is now 2 square root of 2. So I now have this 6 square root of 5 over 2 square root of 2. And what I can do now is, yes, I can reduce this number right here, square root of 6 over 2. That will become 3. So now I have 3 root 5 over the square root of 2. Now I'm going to go ahead and rationalize that, and I'm going to move it down here so I can work with it easier right here. And now what I'm going to do is multiply, again, top and bottom by the square root of 2 over the square root of 2. And then that will get me 3 square root of 10 over 2. And that is actually as simplified as it can get. So that would be my final answer. And then moving on to our last one here. Again, there's a radical in the bottom, but I cannot simplify the square root of 3. So I'm going to rationalize it. Again, multiply the top and bottom by the square root of 3. And then I'll end up with 5 square root of 3 over 3. And that's as simplified as that one can get there. So quick review there of radicals, because we're going to need those today. You can see our topic here today is special right triangles, specifically 45, 45, 90 degree triangles. All right, so one thing I want you to realize is a 45, 45, 90 triangle literally comes from taking a square and cutting it in half. Now that is a 45, 45, 90 triangle. And then this segment down here is also 7. And now to find the length of the diagonal, which we called C, the hypotenuse, I'm going to use then the Pythagorean theorem like we did last week. So remember, the Pythagorean theorem would be a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. So c is the hypotenuse. So I'm going to have 7 squared plus 7 squared equal to c squared. And that's going to be 49 plus 49 equal to c squared. And 49 plus 49 is 98 equal to c squared. And to solve for c, I then would need to take the square root of both sides. And to take that, I know that I can simplify the square root of 98 because it has a perfect square of 49, and it's 2 of those, so the square root of 49 and the square root of 2, that's going to become 7 square root of 2. That is the exact value of the diagonal, is 7 square root of 2. Let's move on to the next one and try this one here in green, where I'm going to put C right there. And again, there's my 45 and 45 and 90 degree triangle. And I can do the same thing as the Pythagorean theorem. 5 squared plus 5 squared equals c squared. That's going to be 25 plus 25, which I will then take and add together to get 50 equal to c squared. And if I then to solve for c, I have to take the square root. And if I square root 50, again, that's going to be 25 and 2. Square root of 25, square root of 2, square root of 25 is 5, square root of 2 is equal to c. Yeah, there's definitely a pattern forming right there. Notice what the side lengths were compared to the diagonal. And lastly, let's do this one. Here's the diagonal. I'm going to use yellow c. 3 squared plus 3 squared is equal to c squared. 9 plus 9 would be 18, and 18 equals c squared. And to solve, I again take the square root of 18, and 18 I know for a fact is 9 and 2. Square root of 9, square root of 2. The square root of 9 is 3, square root of 2 is equal to c. So now notice the difference there. This value was 3 square root of 2 as the length, and that's longer than just 3. Then in the middle here, this value in green, that c was 5 square root of 2, and that's longer than just 5. And in the first one, the blue, that c was 7 square root of 2. So notice the diagonal compared to the side length is just that length multiplied by the square root of 2. That 5 multiplied by the square root of 2 is the length. And then 3 multiplied by the square root of 2 is the diagonal. So we're going to use that and even simplify this even more. So here's just our special triangle all by itself. And remember our pattern. Now some of you might remember this pattern from before. And it's simply whatever x is, because it's a 45, 45, 90, so it's isosceles. Whatever that value is right there of x, I'll have that exact same value there. And then the diagonal, we just found out no matter what the value of x is, no matter what the side length is, I simply multiply it by the square root of 2, and that's the length of the hypotenuse. All right, so that's going to be our pattern for a 45, 45, 90 triangle. Whatever side length I'm given, I know I have 2 congruent sides, because it's isosceles. And then the hypotenuse will be just that exact value of the side length multiplied by the square root of 2. Let's show you some better examples. Here is example 1. Notice my side length is 9, so then this other side will be 9. Well, again, I could use the Pythagorean theorem and go ahead and find 9 squared plus 9 squared and solve it again, but what I'm going to do is just the shortcut is I can take whatever, this is now x. 9 is now x, so I'm going to take, remember the pattern was x multiplied by the square root of 2, so then x is 9, square root of 2, that's that length. I don't need a calculator, I don't need any math, I can just simply know that pattern. All right, here's example 2. Now in this case, notice I'm given the hypotenuse, okay? So remember, if I knew the value of x, let me draw a different triangle over here. If I knew what x was, and x was, I took x and multiplied by the square root of 2 to get the side, the hypotenuse, I mean. So if I know x, to get to the hypotenuse, I multiply by the square root of 2. But if I have the hypotenuse, to get back to a side length, I would have to divide by the square root of 2, is just the inverse. So with my problem that I have here, where I have 4 square root of 2, I'm going to take 4 square root of 2 and just basically set it up equal to x multiplied by the square root of 2. And then to solve, I divide by the square root of 2 and get rid of it there. Divide by the square root of 2, and guess what? They reduce right there, and I'm left with x equal to 4. So I can put a 4 there, and again, it's 45, 45, 90, so these two segments are congruent, so I can put 4 right there. All right, so now I have a similar idea as what I just had. Again, notice that 12 is my hypotenuse, and the hypotenuse is equal to whatever x times the square root of 2 is. So whenever I need to solve that equation, I just divide by the square root of 2, divide by the square root of 2. That goes away, and then x is equal to 12 divided by the square root of 2. Now remember, you cannot leave a square root in the denominator, so I need to rationalize this. So like I did in the warm-up, I'm going to multiply top and bottom by the square root of 2. That will end up giving me 12 square root of 2 over 2. And I'm able to reduce the 12 over 2. And so now I'm left with 6 square root of 2 as my value. And that is what x is, so I can put that on both Sides, because it's isosceles, it's 45, 45, 90. Now take a look, there is a shortcut here, and you can use it. I took my hypotenuse and cut it in half and multiply by the square root of 2 if you wanted to follow that shortcut. If that doesn't make sense, you have this process that I worked out right here. Similar concept on this one. Again, I'm given the hypotenuse, and the hypotenuse is equal to x multiplied by the square root of 2. And so we divide by the square root of 2, divide by the square root of 2. So in this case, x is equal to 17 over the square root of 2. And I have to rationalize the denominator. I can't leave the square root in the denominator, so I multiply top and bottom by the square root of 2. And that's going to get me 17 square root of 2 over 2. Now, 17 over 2 will not reduce, so then that actually becomes my final answer. So I can write it as 17 root 2 over 2. And this side is 17 square root of 2 over 2. Okay, this one seems a little bit different now because my side length involves a square root, so I have the square root of 3. Remember, to find, so that is technically my x value, is all of that. Not just 11, but 11 square root of 3 is my x value. So remember, to find the hypotenuse, I must take x and multiply it by the square root of 2. Well, x in this case, again, is 11 square root of 3, and then I multiply that by the square root of 2. And now I can multiply my square roots, and that's going to get me 11 square root of 6, and that ends up being the hypotenuse, 11 square root of 6. Well, I forgot to fill in the other side length, which is simply just 11 square root of 3. So that one's easy, but take a look here. I just took 11 square root of 3 and multiplied it by square root of 2. Still, even though it had a square root, I still follow the same process, and I got 11 square root of 6, and then over here is 11 square root of 3. Last example. All right, again, here I'm given the hypotenuse, only it involves a square root, and it involves the square root of 3. So don't worry, the hypotenuse is still equal to x multiplied by the square root of 2. To solve for x, I divide by the square root of 2. Exact same process I've done on all the other ones. Don't change everything that we're doing. Now I get x equal to 10 square root of 3 divided by the square root of 2. I cannot leave a square root in the denominator, so I'm going to multiply top and bottom by the square root of 2 and the square root of 2. That's going to get me then 10 square root of 6 over 2. Yes, I can divide 10 by 2, and that will get me 5 square root of 6. That's a 5. That is my side length, so 5 square root of 6, and then that is my side length of 5 square root of 6. This is the homework assignment. Hope you enjoyed it. Good luck, and have a great day.